communicating as temperature sensors.
Well, that's cool, Steve.
Really nice.
I did that one many years ago. And this is my, I had some little learning to occur. Where's my camera? I had some learning to occur where this would connect on here. That's an SHT sensor.
Show that up again, and I'm spotting it.
Here. Okay. See if I can get it on screen here. So this is my board with the P1 FTDI chip. And this is a socket for, oh, sorry, this is a 6-pin socket for VGA video coming out, composite video, sorry. And then this is my 10-degree learning stick. Because the XP chips were so warm that running the SHT sensor any closer actually affected the temperature and humidity.
Yep.
So yeah, I did this board, I want to say, I don't know. I have it written up somewhere. 2007, 2005, I don't know, somewhere around there. Actually, if I can read it, I've got a date on the board.
Ken, your desktop looks very full.
Yeah.
That's Greg Lapola's desktop.
Whose?
Greg Lapola, one of our forum members.
Oh, okay.
Yeah, he sent that in to me. I said, that's a cool picture.
That's a little of everything in there.
It is.
I love that breadboard. It's so much fun to play with.
Yeah, I thought this was a good use too. Look at all the things he's got plugged in. A stepper driver, I don't know, 2 stepper drivers.
Yeah.
And he's got that display that's I think an SPI display. I ordered a bunch of them, so we'd have them. He wrote an object for that as well.
Okay. I'm going to put the mini breakout board on my robot, but the big breadboard is staying upstairs for experimenting with.
Hey, well, how do you feel
I can just move the P2 back and forth.
You need more P2s and more edges. You have the same problem that Kevin R. has.
Yeah, I'm ready to order a couple more.
Happy to hear that. Well, hit record. We don't have a lot of time today because we have a 3 o'clock with Johnny Mack. So I'll just get this started, and we have a number of things to be shared today, I'm sure. So just very briefly, on the housekeeping side, we'll be happy to know that Werfel 21 has received a P2 developer bundle. And the biggest problem so far is this.
AC.
So she's got some e-waste from Parallax already. I thought that was funny. So she's always sticking it to us about video quality and everything. So I thought I'd post that, make some fun of her. Okay, 3 o'clock today, we got Johnny Mack talking about XBs. So we only have one Zoom license at Parallax, so we'll end this at like probably 10 to 3. That's okay, and we'll switch over. There's another registration link. Sorry about that. If people want to join this 3 o'clock meeting, I'll post it at some point here. Documentation, which is a big issue on everybody's minds and #1 topic of all the hate mail I get, has a plan internally now, which people will be happy to know. So we've restarted our effort to get our plan together this morning at 8 o'clock. And this is the picture I grabbed from the team meeting. And what I can tell you at this stage is there will be 3 documents. There's going to be a spec sheet, which is really the first thing we're making because our distributors did not have adequate information when they picked up the P2. And I think Mauser even says it has 2 cogs or something. So we're getting the spec sheet straight so we can bring Mauser, DigiKey, and RS components up to par. And then the next item is the data sheet. And the lead on that is Michael with direction from Chip. I'm just going to do a little bit of muting. You can unmute yourself. anytime. Don't worry about that. So the next item is the data sheet. That's the main technical document with electrical specs, and that's being prepared by Michael and Stephanie with input from Chip. So we got a system here that allows Chip to support the effort rather than have to do it all on his own. So we've expanded our team there appropriately, and the electrical testing will be done by the initial characterization will be done by Michael, and we're knocking off some CE EMI certification at the same time. So within a week, you'll see a PDF of the spec sheet, and the data sheet will also become a PDF and will be released on the documentation side of our page in iterations with small improvements. And the other third item is the Propeller 2 manual. Jeff's taking the lead on that, and I think many of you know Jeff. He's worked at Parallax for 25 years, and Jeff wrote much of the original basic stamp users manual, which is very popular, and some of the SX manual and the Propeller 1 manual. So he has a really good track record of doing a good job on this. So he's taking on the Propeller 2 manual, and that's going to be comprised of some of if you go right now to the documentation page, you'll see a whole bunch of things. You'll see drafts of documents that are Google documents, and they're all called different things. They cover different things. Like one of them is a Rev BC PASM instructions. Then there's a Rev BC Spin2 language documentation. And then there's a SmartPin documentation from John. Those items are going to become the P2 user manual. So my big request is that we make it very clear when we have releases of these 3 documents, and we publicly note the changes we've made to them. So you'll see that happening on the P2 forums. So we're meeting once a week from here on out till it's done. We don't have a schedule for completion of everything, but we're all in now.
One comment on documentation from my friend who just started on the P2 last week is there's too much in the documentation that assumes you already are familiar with Propeller and the old stuff. Like there's not enough description of the most basic things. And
Simple.
He didn't know. So he was like, I don't understand this syntax. So we need a little bit more of the pretend like you don't know anything about P1 or P2 at all and explain the basics.
Okay, I'm hitting record here, so I'll be sure that gets to Jeff. And I'm hoping we can address some of that through the pages on our site that show the tools getting started and then the quick bites. But I think even that might be beyond what you're talking about, Roy.
It was just, I was able to answer the questions for him, but he's just like asking me super basic syntax stuff. What does this mean? Because it was different, and it's not explained. And like the other thing is some people use on a particular example, normally you would use add pins to specify a range of pins on a pin instruction. So you'd say number, add pins number, and that's understood, but some people use the actual syntax of number shifted up by a number plus number, right? Which is equal to the same thing, but the syntax is weird.
Another way of
He's
showing
like, what's going on there? I don't even understand how does it work against more than one pin? Because it's just a number, right?
Yeah, I suffer the same getting started, so we'll get it all right. If it can get past my view, it should be good for that customer.
Sure. I just wanted to make sure that's because I was looking through the existing docs and trying to act like I didn't know, and there's a lot that you just infer.
Yeah.
Some assumed.
Good. Thanks, Roy. In the quick bite world, there have been several new posts. 5 buttons on 1 pin is there, and also Goertzel operation with ultrasonic transducers and LEDs. So it was a big weekend for 1 or 2 GPIO and smart pins. So we get a look at those. And forums. thanks for everybody's help last week to start to get those cleaned up. And if you go there and look now, you'll see that there's a new thread called Propeller to Users Get Started Here. So I'm taking as suggested, the main threads that were very popular and then listing them under here. And then I will unhook those other threads from stickiness pretty soon. Having a little bit of trouble with the inability to use formatting to present this material in a useful way, but we're going to do another form upgrade in about 2 weeks. So that should help to have sub-bullets and things. And right now I can't even find the flex prop thread. So if anyone wants to paste that in the chat, I'll also add that to this. So I'm not totally done, but we're on our way there. Yep, and next week, actually 2 weeks from now, we'll be doing some stepper motors. And everybody's already been doing so much. It'll be interesting to see what we have here. So get your motors. And then for today, we can discuss anything. I know there's a number of topics: the arcade board, P2 Cube, Prop Tool, Visual Studio Code, and Kevin has KevinBot 2. So maybe we can just kick off with KevinBot 2 for a minute or two, and then move on to anything else. Kevin, are you there hanging out with your robot?
Yes, I am.
You want to show that right now?
Yeah, and I also have a surprise.
Oh. Okay, you're all on.
Well, is it kind of hard to see with the lights really bright?
It's clear. Looks good.
Yeah, that's good now. Okay, so it actually, I can show the arms. It's kind of hard to control like this, but run version 3. Yeah, it's based off a Raspberry Pi 3, and its head actually has stepper motors now, so it can actually turn. It's got one of those boards in there. So here are the arms. One of the arms. This one isn't made yet.
That's pretty neat. Were those arms that you printed?
Yeah, these have been all 3D printed, including the gripper. And here's the gripper.
Nice. Now, are you controlling that remotely at the moment?
Yeah, it's using a keyboard. It can also talk.
Yeah,
well, it can't talk to this program yet because I'm still developing it. So to have it talk, I need to just directly open up the terminal. Well, let's show the head.
Phenomenal.
What are these eyes?
These are, if I take the XBs out of the head, they're little screens with Arduino Nanos in them.
Wow.
And here's the surprise. It can do much more other things.
Put the screw back.
Oh yeah, I'll put this screw back so it doesn't. Okay, so here's the surprise, and
but he needs to be there. Gracie needs to be in the full screen.
Yeah, we have your video showing.
Yeah, I know it's actually got face recognition.
But King Gracie needs to be in full screen now.
Oh, I see. You want me to do? Okay, gotcha. Here I come.
There. See if it works.
Hi, Bill. No, wrong person.
Well, we called you.
Oh, no.
Not very great working through computer screens.
Yeah. I guess you found that out.
Very cool.
And the
Supposed
lights,
to say hi, Ken.
yeah, the lights can change colors and do animations.
Wow. Show us that base you have. We're sending you, with the help of Roy, those HP25s you got. We'll control the larger motors that I've not packed up yet, but those will be coming your way soon.
Yeah, the base on here is really bad. It can only go forward and backward, and it can sort of go left and right, but just barely.
Yeah, that problem will be solved shortly. Very cool. Any
Thank
questions
you.
for Kevin?
I need to put the
Kevin, you
XP
could add a subwoofer to that.
Oh, yeah. You had to cover the eyes. They put robots on it.
Very impressive. Nicely done.
Awesome.
Thank you.
Yeah, thanks for sharing. Okay, next topic up. Anybody?
I can show the arcade board.
That'd be cool.
Let's see. We got these back yesterday. Here's the P2 Edge with a special board that Michael built. And it has 8 RJ45 jacks on it. And he sent me 2 of these boards that he built up. So each board, this kind of simulates what will happen in the arcade cabinet. Power comes in along with the button signals. And here I have the buttons running. You can see, I don't know if that actually is visible, but I made the program live so it shows, what I'm pressing. I'm just working on the PAL and NTSC driver for this thing now so that we can do pretty, a whole range of resolution modes that games might use. And then Baggers has been writing some programs that actually can run on 8 machines concurrently. So this thing works nicely. I do see that we have here like a 50, well, on this cable, maybe a 25 millivolt drop because power is brought in over this cable. And the monitor here, let's see, I have another program that can run that. The monitor takes about 350 milliamps at, oops, I gotta kill this one. Yeah, 12 volts. So that puts a load on the ground and power wires, which causes ground to rise about 25 millivolts locally on this. But because our buttons, have their own ground return, that's no problem. Between 730 microamps and about 1.3 milliamps flows in this button circuit. And let's see here. Oh, I got to kill so many things open. So let's see. I had this thing running a minute ago. Oh, wait, that's the wrong program. This one here. Yeah, if you can see that little thing. So this is NTSC. Baggers gave me a screen with a bitmap so I can compare so I know when I have this thing about right. On the monitor, I see it looks kind of green, but here it's pretty blue. So it looks balanced to me. So anyway, this thing's coming along. I just have a little more work to do on the drivers, then I'll turn it over to Baggers, and we'll have the buttons working, the audio, the video, and then this board. So it kind of turned out nicely. Almost done with it. Hey, one other thing I want to show really quick. There's this program called Processing. There's this program called Processing that's come up a few times. I added a command line switch to the PNut tool so that if you just do PNut -debug and then specify a COM port, and then also an optional non 2 meg serial baud rate, what it'll do is it will, see, for example, I'll turn this thing off now, so it's off, right? And then over here on this thing, I'll do this PNut debug 6. And up here, you can see there's a debug window. Now, when I turn this board on, it automatically, just starts running whatever debug stuff was inside the flash. So this thing is quite agnostic. It doesn't really require any propeller to run. It just takes serial strings and then opens up all those debug display windows as it comes in. Because the way this thing works is all the debug data resides in text strings or things that are dynamically produced. And when your system spits out those strings, it completely instantiates all these windows. So what you can do now is have it so that without needing any particular like IDE, you can just run this PNut in debug mode and it will display anything that comes across using all those debug facilities. And so,
is that the program that Carol brought up a couple weeks ago?
Well, yeah, she brought up processing, which is something that's out there. I'm pretty sure it's an open source product, but this thing is just what we have in the PNut and also the Propeller tool debugger. But it's been set up so that you can just run it over command line, and all it will do is receive and present debug stuff.
Cool.
Chip, you might want to mention the customer, their application is to be able to just hook up the P2 and show data, right, from a machine it's connected to.
We have a friend here in Red Bluff that we used to work with at Parallax who works with this company called Sierra Pacific, and they're basically like a sawmill that makes lots of wood products, and they have a lot of heavy automation there. And he's been using the P2 chip to replace all kinds of legacy boards that they can't rebuild because they can't get parts for. A lot of it's simple stuff, like you have to count pulses, and then control some actuator or something. So we've been able to replace all that stuff with literally just a couple of lines of spin 2 code using smart pins. But what he wanted was a system where for their techs and engineers there, they could just, come up to it and see stuff. So the obvious thing is, well, you can have it send out serial messages, right? But better than that is to be able to show stuff graphically. So this allows him to, say in one cog, do all of his debug stuff. So it's not holding up the timing of any other process. And it just looks at critical variables and then puts them into various debug displays and presents them. So the engineers can walk around with a prop plug into this thing and run this debug program and get a full report of whatever's going on inside the machine without needing any IDE or programming tools. So it's a little better than just a video output because you don't have to have any memory buffer and graphics routines to drive anything. It's just this text string stuff. So it's just kind of, low barrier to entry, graphical visualizations of what's going on in embedded systems.
Chip, have you already released that on the PNut thread?
Yeah, if you go to the P2 forum, go to the newest version of PNut, it's all in there. So what you would do to use this is you would do a control from PNut, you would do a control F11, which would download with debug and program the flash. And at that point, your program has the debug stuff in it. And like I said, you might want to partition all of your debug statements into a separate cog that won't suffer any kind of loss for having to send serial messages, and just have it kind of passively report status data in the system. And then you can, just observe what's going on and you can see what the machine sees.
Well, questions or comments for Chip?
That looks really good, Chip. That's fun.
Yeah, Chip, and thanks for finishing up those 2 quick bites last weekend.
Yeah. Someone asked, Carl Snell, yes. So, okay, can you answer? Yeah, you can run 8 games at once. The idea is that with this board, there are 8 connections here, right, on this RJ45 connector. Half of them are ground, and then 1 is 12-volt power, and then 3 are pins right off of the P2 edge. So 3 pins will run a whole game cabinet from this. 1 is the video out, which is like composite NTSC or PAL. The other is audio, which is just monaural. And then the third one is this button scheme where we have 5 buttons connected to 1 pin that gets resolved over an analog to digital converter. So every pin has an ADC in it. Every pin has DACs. So it takes 3 pins to run a whole game cabinet. So here comes, you know, this represents what will be in the game cabinet, although it's even more complex because in the cabinet, you won't need a lot of these resistors. You'll only need the precision resistors for the buttons. But incoming on this cable is a 12-volt supply, which goes out here to that little monitor there. And you have the audio, the video, and the button signal. And it only takes 3 pins off of this thing to support each cabinet. As you can see, we're set up to run 8 of these things concurrently. You know, at a cost of what? 3 times 8, 24 pins.
So Chip, also, it looks like you'll probably have some power draw for the audio amp as well, right?
Right, so I'm thinking that the only problem I'm seeing is that we're lifting up ground by 25 milliamps by drawing, you know, 350 milliamps over this cable. And by the way, this is like the lightest cable we could buy. We figured none of this heavy solid core stuff that like dictates where everything lays. This is like a very lithe cable. We have another one here. It's like just very supple. You know, it's made out of stranded wire instead of solid core. Now this, I think, is a 3-meter cable. This I noticed like maybe 50 or 75 millivolts of rise on ground, because as we're using, you know, we're bringing in ground and power, those things pull together. And so our video signal starts looking relatively negative. But I think that, you know, most systems capacitively couple that thing anyway, so it doesn't seem to matter. But the buttons, which is very sensitive, you know, it works, it has to discriminate like 15, 20 millivolts. It has its own ground return, and only a very limited amount of current ever flows through. So these cables represent no voltage drop in that case. But it looks like it'll all work okay.
And Chip, where are you headed next after this is worked out for baggers?
Then I got to get back on the single-step debugger. It's funny, I wrote the disassembler for that like probably 6 weeks ago now, and I've never even tested it because I keep getting off on these other tangents. I want to show one other thing, but maybe you guys talk for just a minute while I set it up.
How about if we bounce over to Stephen and he can show us the Visual Studio Code efforts?
Yes, that would be good.
Is that okay, Stephen? Okay.
Yeah, I'm just muting myself. I'm going to go ahead and share screen. What I've been working on the past couple of days is documenting how to and then demonstrating how to do compile and build using FlexBin. And so I'll show you the result right now. Let's see. Tell me if you can see my screen.
Yeah.
Yes.
Okay. What I'm looking at now is just one of the Johnny Mac demos. And my theme is a little bit more bright because I'm looking to see what's exactly annotated with syntax highlighting and stuff like this. So that's what you're seeing in this window. I will close these windows here. Sure, I will. All right. So this is a typical trim window. Let me get the display out of the way. So here I am in Visual Studio Code. I downloaded a couple extensions that do some pretty nice things. And I have on this machine also FlexBin. And then when you're going to automate, I've got to change my window size here so I can see the things. A couple things are important, and that is that you'll notice in this directory, which is kind of non-standard, is the VS Code directory. You can see this on my left. Here's the Johnny Mac files, spin files. And because I've compiled it before, there's a P2asm sitting here. I guess I could delete that one. Not important, so let's get to the demo. When you want to do tasks such as build and download, you're actually creating a small JSON file in here, and I'll have these all up at my website. And these actually describe what should be done. And this is the task to compile P2, and this is the task to download P2, and it's running load P2, and it's running FlexBin.
Can you zoom in on that code just so we can see about how complicated it is?
Which code?
The code that invokes the compilation and download.
That's it right there.
And Chip, you could zoom too. Do view options up top.
Yeah, just so that we can just get an idea of like what the commands look like. And
there's nothing.
I don't know anything about it. So.
Oh, it's basically you invoke FlexBin. It looks a little bit more complicated here because I'm using absolute paths to where they are located on my system. But basically you invoke FlexBin with a -2 and then the file base name, and it'll compile it. But I'll have all these, so you can cut and paste these into your environment. Longer term, we'll actually be able to add them to your environment automatically. But for right now, I have this file. So I'm going to show you what kinds of things happen. First, I'm going to create an error in this code so that you can see something pretty fancy happening. You see me modifying a called method, and I just added the X character in it. And now I'm going to use the default build task. And you see it executed, and we have a couple things that happened. It executed the build tasks, and you see that in the term window. It generated errors. I don't know exactly why there are 2 of them, but we'll, but the point is, you see the error message displayed up next to the code. We ran the compiler, detected the output from the compiler. It parsed the output from the compiler, put them in a list of problems right here, and then it automatically took that error because of another extension I'm using. It's called Error Lens. It took that error and I added up here in the line of code that contains the error in red.
So it probably tells you like the file name and the line number. Is that how it works?
That's correct. So if you look at the terminal, here's your line right here that contains it, right? And so it's file name, line number, and then the error message. And so this was automatically parsed by my task and then handed back to VS Code. VS Code, because of an extension called Error Lens, took that and colored the files over here so you see which file has the error. It also added this text next to the line with the error. So now if I correct that and do Command-Shift-B again, you'll see that it recompiles the file. There are no errors and the error messages go away.
Oh, so are you saying it made an error message, but it also highlighted the same text?
Yeah. So watch when I change the code now. I'll change this to bar X. All right. I'll save it and I'll do a compile and watch what happens to that line.
Now, did it know the offset in the file for where that data was, or does it just do a text string and go, oh, there it is, highlighted?
No, no, I'll show you. Let me clear that again and recompile. But then I wanted to show you one more thing before I do this. I'm going to save this and recompile, but I'm also going to download. And so this time, the terminal window is going to show the compile. It compiled clean. And then it executed the task, and it just downloaded to my machine. Well, terminated with Xcode 1. What did I have? Do I not have the power on or something? Anyway, this actually then performs the download. So you saw a compile run, then a download, and my P2 isn't there on my machine right now. Thank you. Why? I see you. Why don't you see you? Anyway, ignore that. Go back to now, press any key to close these terminals so I don't have them all sitting around. All right. So the point is, how do you extend VS Code? You add tasks, task definitions. The task definition has a problem matcher. You see me highlighting it? It's using regular expressions to parse the output, and anything that matches it knows it's found a file, a line number, severity, and message, and it passes that back. And that's what triggers VS Code then to highlight the files on the left. And it also triggers the error lens extension to VS Code to take that text, error message text, and put it on the line affected.
Wait, if you had the same source text that caused an error in a few places, how would it know, or would it just highlight them both?
All right. Well, that's a good question. It should highlight any errors that we have. I'm just going to go create a couple recognizable ones. In fact, let's do that. I'm going to do this, something really radical here. And let's just compile. And so it all depends on the errors put out. It looks like FlexSpin is only, it's putting out, what happened?
You usually stop at the first error.
Yeah,
that's
okay.
What's going on.
Do we have a command line switch to do multiple errors?
I don't know.
Okay, but anyway, so it's identifying the first error. We have to fix that. Save it, build. Now it should identify subsequent errors. Whoa.
The other one wasn't an error because it just made it a local variable instead of a passed in one.
No, it shouldn't have. It shouldn't be defined unless there's a bits defined somewhere else. 1 of 7. 1, 2, 3, 4, 5, 6, 7. It should be an undefined. Does it automatically assign locals?
I don't know. I mean, you're dealing with spin or spin2 on FlexSpin. I'm not super familiar with that. I've only done C on FlexSpin.
Yep. So spin2 on Flex looks like it might have an error there. That's interesting. So if I change the error here, I'll file these with Eric and let him work them out. So I changed what the error should be. Oh, I know what it is. I'm out in control. I'm in a wrong file. That's because it doesn't have a sense. It only compiles the current file. It doesn't have a sense of top file unless we add that. And so we might have to add that. That's what's going on. All right, let's get back out of this. Get back to this. Thank you. What can I modify here? What happens if I do this? Okay.
Anyway, Chip,
So
normally if you get multiple errors out of the compiler, it would highlight all of them.
All of them simultaneously,
Right.
correct.
You'd create a list. That problem list would have multiple entries, and you could click on them, and it would take you to them.
Right.
Right.
Yeah,
It'll take you to all of them. The thing that you're seeing here, Roy, is that if it had multiple errors, they would all be annotated with these red lines. And so
Yeah, no, I get it.
right? You see the red text, and now you can see the red lines over here too. So if you have multiple errors, you can just navigate on the right-hand side to the errors. And if it's multiple files, you'll see multiple files over here highlighted red. And you have the problem output here. So this tool gives you lots of ways to navigate to where the failures are, right? But anyway,
So all we need is a compiler, Chip's compiler, to output error lines in a similar format, and then his compiler would do the same thing.
As long as his compiler outputs error lines in a consistent format, we can make a parser that understands that format.
Yeah.
All right, because it's regular expression matching.
You know,
Now, what I'm not demonstrating yet, but will have demonstrated, I'm going to switch screens now. What I'm not demonstrating yet, but will over the next day or so, is we actually have file watchers built in for other languages. by incorporating that in our Visual Studio environment, we can now use file watchers and monitor file saves and automatically compile download if we want to go that far, or download only if the compile succeeded, kind of thing.
So it's kind of event driven.
Yes, and so all of that now can become part of your Visual Studio environment. I'm going to share a different screen. All I can do is find it.
Let me know when you're ready for a few comments, questions.
Okay, I should be done here momentarily. This will be the last thing I have. Where's the screen I'm sharing? There it is. Okay, this is the GitHub repo for VS Code extensions. I'm showing this because there are some fun things here. If you're new to VS Code, go down here to the environment, and you'll see in this part of the section where I'm adding a couple things. VS Code can do that. Go to that link and review it. It's good stuff. Here's a YouTube channel that has probably 40, 50 short videos that show you little tiny things for how to do things in VS Code. But more important to us is here are the VS Code extensions that we're already using, and Error Lens is the one that puts those red lines up next to the code. We have an ability to edit binary files. We have an ability to mark to-dos and fix me's and undones and things in the code. And so when you add these three extensions, just the same way you add Spin2 extension to VS Code, you get some really nice things. If you were running VS Code on multiple platforms, maybe a Windows machine, a Linux machine, and you want to synchronize your VS Code installations, then Settings Sync will keep all of your respective VS Codes in sync with each other in terms of setting configurations and extensions. So good things to have. So I have these kind of things out here, and as those of you use VS Code in P2 and you find things really useful, message me, file an issue with this repo, something, and we'll update this documentation so we can share a consistent list of what kind of things really help us with VS Code. Another thing I'll have here, and this is where you can see, Chip, what I'm doing. Hello, sorry. Configuring tasks. As we figure out how to work with each tool, such as FlexSpin. Why is that highlighted? No idea. Thank you. Don't do that. Anyway, here's the task snippet. You can cut and paste this into your task file, and it will run. This is how we run compile, and this is how we run download. Then keyboard assignments are a separate thing.
That's what was too small to see earlier, right?
Okay, can you see it better here?
Yeah, yeah. It's the same thing we were looking at before, though.
Yes, it's exactly the same thing.
It's readable now.
Yeah, and so what you have here is this is how you set your default build task for Command-Shift-B. Once this is default true, is set on one of these tasks, that's going to run behind Command-Shift-B. I then also did a keyboard assignment to take download P2 and put that on Command-Shift-D for download. And now I can just do single keys, chorded keystrokes to invoke either one. And so that's what that has. As we figure out FlexSpin, as we figure out maybe Catalina, anything that runs on different platforms, we'll add the stuff here so you can invoke it. I should fix spelling, huh? And so you'll see this all here at the repo. Here is the tasks reference page for learning how to compose these tasks. And I want to go do one more thing though. Last thing I have is future directions. We have an issue with tasks, and that is the binaries for the compilers, PNut, FlexSpin, Catalina, whatever you're going to use, can all be installed in different places on different machines. That's going to become rather problematic. If you know your machine, you can write the tasks. If you ever move the compilers around, all your tasks will break. That's going to get just really fun after a while if we don't have standard locations to install things. FlexSpin, for instance, is intentionally not given a standard location, so it can be put on flash drives and things. But what we'll probably do is figure out ways that we can mark the system, maybe a shell environment, an environment variable. So from the shell, we'll just know where things are installed. Once we do that, I can author a task provider. That's why I have this highlighted here. We can author a task provider and add it to P2 users' VS Code environment. It will then study for those signatures to identify where the tools are. and then can offer the tasks for compile and download or any others we feel that are useful, and pre-build them for somebody starting a new VS Code project, a new Spin 2 project. So that can help this longer term. Right now, I'll do them manually while we figure it all out. We can cut and paste manually. Longer term, we can get to a task provider. Spin 2 also supports formatting and beautifying. So longer too, we can do a Spin 2 and PASM formatter beautifier and have that automatically readjust our code layout, indents, line breaks, whatever you want, and get everything normal. So every time you want to check in and share files, they'll all have the same standard layout. Snippets, we can actually do, I can ship code snippets as part of an extension. And so now when you look at giving common things we do in Spin 2 or PASM, we can have snippets by name that might set up smart pins for an ADC or for a DAC or for SPI or whatever you want to do. But anything that we do commonly, common methods, common whatever, common uses, common includes, if we find that the community has frequent things they want to do, we can add snippets and just share those snippets with everybody through an extension. And lastly, should we have a code beautifier, task provider, themes, maybe the, of course, the syntax highlighting for P1, P2, we can actually group all these together in what's called an extension package. So people can say, just give me all of the Spin 2 support, or all of the Propeller 2 support, all of the Propeller 1 support, and all the packages will be loaded into VS Code simultaneously through one install. So these are future directions we can go with the VS Code environment. That's all I have. What are the questions?
I have a couple. First, the comment. This is awesome.
Okay.
I think it opens a lot of doors for all of us. And I think you answered this one, future directions. The scripts that tie everything together and make the download occur, will that move towards a button for customers like me and Roy's friend?
We don't, in VS Code, we don't have things like buttons, but we could, I suppose, build an extension that presents that kind of interface. What we tend to do instead is we create events like file watchers, and we'd probably set up a standard for identifying a top level file. So if we see spin files change in a project, we'll recompile the top level and everything included, and then do it down automatically.
You can assign a key to the command though.
Okay.
Yes,
yeah, that works.
That's the normal thing as a key. You're not going to present a button on the UI.
Yeah, I got it.
Correct.
That sounds fine.
Sorry.
So you just have to have that.
Mentioned that already, key bindings. Right.
It's just important to have that script in the right place and have it say the right things then.
Correct. And
okay.
The task provider would help you build the underpinning scripts. And VS Code has already, for certain environments, suggestions for tasks. And so you open the Command-Shift-P window up there, and it lists possible tasks you can create or customize. And then it just moves them to your task file for that project. And so we can have that kind of contribution, or once we select it, it can do the move for you automatically to your project for the type of tool. So you say, show me what kind of tasks I can add, and it'll say, hey, I see FlexSpin on your machine. I'll give you these FlexSpin tasks. I see Catalina, I see PNut, I see, and it'll just give you tasks that you can then say, yes, I want that set for this project, and it'll move them to your task file.
Yeah, very nice.
Longer term, that's what the task provider does.
Same thing, more than a button. And can you briefly comment on the Mac driver success, which you've experienced? And then
sure.
Super fast, if you could, on the marketplace part, you mentioned the extensions. I think this is really important. People can just go download Visual Code Studio, search for Spin 2, and hit install at some point in the future.
I'm going to go back to my code environment so we can see this. When you're in Visual Studio Code, you have these options on the left panel. You'll see that I have many things here, a lot of which you haven't seen before. Ignore all of them. The important one for right now is extensions. And so when you install new VS Code and you do something like, well, yeah, can I spell? And you actually spell Spin 2, you'll see this come up. And there's our new Spin extension. And you'll see you have an install button right here, and you just press install. And that's it. It's now installed. Anything that we're talking about, task providers, theming, an expansion pack, the snippets, can all be combined into various different ones. And so I may put snippets in here, and I may put task provider in here, or I could have those as separate extensions, in which case I'll probably mark them so you can do search keywords, and you'll see all of our extensions come up. Does that help, Ken?
Yeah, it does.
And so install is super easy. You press install, it takes seconds and you're done, and actually download it from the network, added it to your environment. And sometimes you're given a question, do you want it installed for this particular environment or globally? I get asked that question because I run Docker. And so I run things inside of containers sometimes, such as when I'm developing this extension. And that gives me a whole canned set of tools that I can use to develop the extension with that aren't installed on my machine. They're kept in my Docker container, and I can download that Docker container to multiple machines and have the same context in each machine.
Any quick questions for Stephen?
And then here's your key bindings where I did Command-Shift-D, run task, download P2, just so you can see what that looks like.
Could that thing potentially like grab a file off, like let's say that someone has a driver that they're updating periodically. Could it at compile time just grab the latest one?
If we structured a server such that there were conventional URLs or a REST API to get to those pieces, then yes, we can build an extension that will grab and update the latest drivers. So for instance, you could automate the interface to LBEX and have literally give me this piece from LBEX, give me this piece, and create, you create files. And I wonder if I've got a project here I can open. I didn't even get to demo some of the things. You ask me questions, my mind wanders.
No, that's okay, but that answers it. It makes sense. If there was a URL at which a file sat, that could be updated by the owner, and then it could be grabbed on each compilation.
Correct. And it couldn't be grabbed on compilation. That's maybe not where you want to do it, because while you're debugging, the context may change out from under you. But yeah.
Kind of brave new world. I don't want to do that myself, but.
Exactly. But what you do is when you're first setting up a project, you create these dependencies, and there's actually good design patterns for doing this kind of thing. And I don't know if I can get there. I can't get there here, but there are good patterns for doing this kind of thing. We can create a JSON file that says, I want these kind of things in my project, and it will go out and get them, and then it will actually inform you whether you've got the latest or there are updates. And so every time you open the workspace, you can go up and look, are there updates that I would want, and just get them. There are frameworks for doing that already. And so all we have to do is build sufficient peace to let those frameworks do their thing. So yes, that can be done. Let me show you one other thing. This is the extension. You see hidden items on the bottom left of the Explorer. And you see here, I have spin2 files, PASM2 and things like this. I'm going to say, add to hidden items, all subdirectories PASM, and say okay, and you'll see if I enable it, it's already enabled. Why didn't my update happen? That should have gone away. Say, oh, it did, okay, once I get back there. Same thing here, I'm gonna hide binaries. And now, hello, did I invoke it? Yes, and so now you see when it got a chance to update, now I'm seeing only spin2 files. And so hidden items is a nice new extension you can use, and that's in my list of extensions for you. Okay, done here, unless there are more questions. And thank you for your time.
And for somebody who wants to get started, your GitHub or the forum thread?
Get started, install VS Code, install a spin2 support, and then there's a repository link in the spin2 piece that you just added, and then hit the repository link from there and you're connected. And then at the repository on the README is all the necessary things to learn about VS Code, help with setting up the tasks, things like this. And that'll get better over time as we learn more about how to do the different compilers and how to set them up on different machines. They'll just keep getting better and better. Eventually, the betterness will be wrapped up into a test provider. But
I think what Ken wants is a single link to put on the P2 forum thread to say, go here for VS Code information from Steven's stuff.
Then I'd say, let's do the, I don't know. What do you think, Roy? Which is more useful to you, the repo?
Your README is pretty comprehensive, so I would say go directly to the GitHub because the README there has all the info.
Okay, let's do that. And
sounds good.
Let's just put a link to the thread in your README on the repo so that people can get back to the thread.
Perfect. I'll just cross-link the two and we'll have that. It's easy.
Could you post that exact link in the chat, Stephen?
Yeah, this was me searching for it and not finding it before you asked that question.
Well, this looks great.
I was trying to beat you. I was trying to have an excellent answer for you, and I misplaced. There it is. All right. Here it comes.
Okay, so we have about another minute before we move over to Johnny Mac XP. So, Chip, did you have something to share that was quick?
Yeah, I've got, let's see, I have a little Goertzel thing here. I found these at Amazon. They're really cheap. They're very efficient. These are, they're not weatherproof like these, you know, waterproof outdoor ruggedized piezos, but they're super high Q and they're very, very efficient. So these things for $10, you can get 10 pairs of these things. That's a transmitter, and then this is a receiver.
Jeez.
And I have it wired in just straight to the pin. There's no passives involved. So then I have this little display going over here. And it's bouncing. This one here is shooting up to the ceiling, goes up there, bounces back down, and hits this guy. And so if I'm still, whoops, let's see, you can see that. You can see where that thing is, right? So it's taking 100 samples per second, and it's wandering around just because of, I think, ambient air environment issues. You know, just little, but watch this, if I blow on it, I'm going to create a Doppler shift.
Fun. And what's it transmitting and receiving?
40 kilohertz.
Oh, okay.
So the wavelength is really short. I have it pinned down like this, but watch, I can grab this thing, right? This is a clear demonstration. It's bouncing off the ceiling, right? So if I put my hand down here, if we can see everything together, let's see, try to get the camera. You see that? If I go down, it unwinds. Whoops. So it's shooting up to the ceiling and I'm moving this receiver up and down. And you can see it gaining phase. So
yeah.
But anyway, you can build anemometers and things out of this sort of technology because the wind blowing across a transmitter and receiver creates a Doppler shift. I think we have one guy who's been using the P2 to do this kind of thing. But the Goertzel makes it just really simple.
That's amazing.
It's, I mean, if you look at how smooth this thing is, I mean, look at that.
Yeah,
it's very natural. It's not like there's even any electronics involved. It's just sort of, you know, where you move. Anyway, that's what I wanted to show.
Super cool. I just posted a link to the Quick Byte chip.
Okay, good.
And we're going to get those transducers in stock too. Wonderful. Okay, so I'm going to stop recording and I've pasted a link to our 3 o'clock presentation with Johnny Mac. If anyone wants to head over there, we'd like to see you there.
All right.
Be there in a minute.
All right. Thanks, everybody.